7b, let's try to do it as fast as we can. It says, show by calculation that p is between 0.5 and 0.7. All right. So anyway, we know that at p, we should get 0, right? If we are to throw in p, the point where p is we should get a 0. If I put 0.5, I should get a negative and then 0.7 a positive, or 0.5 a positive and then 0.7 a negative, because there's going to be a sign change, because this is 0. This is a maximum. It's a turning point, right? So if I come from here, since it's a maximum, then the left should be positive because the function is going up, right? It is going up. Then from here, it starts going down, which means the gradient is going down, which means it should be negative on the right. So when I put 0.7 into the function, I should get a negative answer. Then it would have proved that p is between these two. That's how simple it is. Now you say to me, where do you put? Now, since you are checking as to say that the p is in between these values, you are putting in the function of p. So let's go back and see function of p. That's the question we have. So anyway, here the question, it said show that it satisfies. Let's say you did not show. Let's say you didn't get to this. You would come and take this show. Okay, what they say that is. So they said p is equal to half tan inverse of 3 over 2p. We are lucky to have found it. We're fortunate. We've found it because we did well. But if we hadn't, we would still just use it. P is half, their p, half of 3 over 2p. You use their solution, right? Now, how do I make a function of p here? I just need to leave 0 on one side, okay? I need to leave 0 on one side. Then I'm going to change that 0 to be an f of p. That's always what we do, okay? And I like to take things where p is because it's a function of p. So I would say, okay, p, then I'll take this half, so it becomes negative half tan inverse of 3 over 2p. It's coming here, and it's equal to 0 now. Now, which means we'll say this is the f of p. So we can say f of p is equal to p minus half tan inverse of 3 over 2p. Now we know that p is between 0.5 and 0.7. So these are values on the left and on the right of p. So we're going to substitute them in terms of p. So we say you say first, let p be equal to 0.5. So we want 0.5 instead of p. We would have f of 0.5. For p, it was going to give us 0, but here we would now get 0.5 half tan inverse of 3 over 2 by 0.5. Let's punch this in the calculator. So it's going to be 0.5 minus, so 0.5 minus, we say half, 1 over 2, multiplying tan inverse, so second function tan inverse of 3 over 2 times 0.5. Can you see we're getting a negative solution? So let's see now. Did I do everything correct? 0.5 minus. Okay, so yes, this is what you should do. I'd found negative 35 or whatever, but we changed it to radians. So we punch radians. So we should change to radians. But why am I changing to radians? We can still use degrees if you want, but then we wanted some values here that we could use. Okay, whether it's degree or radians, fine. So here I'm opting to use radians. I would recommend you to do that. What would we get? We're going to get a negative solution. We will just compare the solutions. Even for degrees, we're supposed to get a negative and a positive one to show that it is between them. So we will now say what is we can find f of p again. F of p just means that this is in terms of p. Okay. You can call it g of p or whatever. This is just the name of the function. It's called f or g or h. We don't care. And it's a function of p because on the other side is p. It's represented on the other side in terms of p. So you can put it again. It is p minus half tan inverse of 3 over 2p. Now we'll find f of 0.7. This is equal to 0.7 minus half tan inverse of 3 over 2 times 0.7. Now let's punch this. So where there is 0.5, I'm now putting 0.7. So what do we get now? Here we are going to get a positive. So here we get a positive 0.00291 or 292, right? Positive 0.00292. Is it? let me see, 0.7. Oh, here it is 0.5. Sorry, 0.7 minus this. It's 0.0. Sorry for that. It is 0.0 or 0.1329. So 0.133 if you put it to 3 SF. So you can see that one is negative and one is positive, right? And because of this, you are going to be able to say that P is between this. So you can now here say, let me just write now one statement which we're going to put at the end to cap off this thing. Would now say that all right, now you're going to say here, since f of 0.5 is less than 0 and f of 0.7 is greater than 0, then you can now say P is between 0.5 and 0.7 because there is a sign change. So it is always in between a sign change because it is a maximum. You can see on the left there is an increase, on the right there is a decrease. So you've proved that it is between them because it is not an increase, it's not a decrease, it's a 0. So that means if it was increasing or decreasing on the left and increasing on the right, if it changed, that means in between there is a point where it was 0. Okay, so if I was increasing and I'm decreasing, that means there's a point where I tend. So that's what it means. So that's why we have proved that. And then you can now say therefore 0.5 is less than whatever. And you're done. This is going to be it, and you can go on to the next one. Goodbye for now. Let's see you in part C.